Guys, how are you? My name is Konstantin. I'm from the iconic. Originally, we are from Russia. We moved here from Moscow just 7 months ago. So I'm quite new here in the PHP community in Sydney. I'm not an expert on PHP, as well in Rabbit, but I would like to share some of my learnings and some of the experiences I had putting these technologies together. So as you probably know, RabbitMQ is a message broker. And I guess that almost everybody here has used this message broker at least once in their lives. Many of us, we do it maybe on a daily basis, or the system we develop, they do use RabbitMQ. And funny thing is that even though we keep using this, sometimes we use it on a very high level. So we don't dig really deep into its technical details. We just say that, okay, there is something in the middle, some kind of middleware, messaging middleware. We just implement producer, consumer, and that's it. And I was this kind of person. So I used Rabbit, but I didn't really understood how it works. So I decided to dig a little bit deeper. I haven't become an expert, of course, no, but I think that now I have something to share. It's going to be a very basic talk. It's going to be a very entry-level thing, but maybe it will be a good inspiration to dig deeper if you feel interested in this technology. Okay, so let's go to the first slide. Imagine typical situation that we have some kind of UI service which is talking to some, I don't know, microservice, backend microservice, and this backend microservice is talking to another microservice. Imagine that this guy from the left, he is going to buy something, new pair of shoes. And the order service we see here is going to update the stock. Imagine that the operation of updating the stock would take 5 seconds. We don't want this operation to affect the user experience. We don't want our users to be waiting for 5 more seconds just because we need to wait until our stock will be updated. The problem is PHP isn't asynchronous by default. It doesn't have any native functionality which would allow us to perform operations asynchronously. It's always synchronous. So what many developers do, they apply some kind of middleware, some kind of message brokers to have this kind of asynchronous working in PHP. So if we rewrite this example, if we imagine that order service would talk to stock service asynchronously, the operation will still go, will still pass, but it's not going to affect the customer experience. It's just a typical situation why some people decide to use Rabbit, but of course not the only one. And sorry, I'm not really good in building slides, but no worries. So the thing we need to know that RabbitMQ, why many people choose Rabbit, because the most widely deployed open source message broker. It means that we have a lot of documentation and a quite big community. So probably you will find any answer to the most of the questions you may have about this in the internet, which is good. This is one of the advantages over Apache Kafka. I will talk about Kafka a little bit later. So some of the use cases, of the possible use cases for Rabbit. The first one is when we communicate between multiple applications, just like in the example I showed you a few slides ago. So instead of waiting for the response, we just send it to the message broker. We don't wait, and the operation will be performed. Example, order status updates, or perfect example, email or SMS sending. This is the most classical way of talking to the SMS or email senders. We just put the message to the queue, we don't wait, and then this message is consumed by this SMS provider, for example, or microservice, which is talking to the SMS provider, and it doesn't affect any customer experience, which is cool. Or we can perform some kind of messaging within this single application. And as an example, we can recalculate some big report after some customer's action. Again, it doesn't affect the experience. It doesn't take any time of the customer. Of course, these two, they are not the only use cases of Rabbit. There are a lot of them, and we're not going to be focusing on all of these use cases. Now, let's talk about another very important thing I didn't really understand before. This is called AMQP. For some people, it's like a synonymous for Rabbit, but in fact, it's a little bit different thing. AMQP is a protocol. It's not a product. RabbitMQ is a message broker. It's a product, we can say, but AMQP is a protocol. And mostly, it's getting developed not at the same pace as Rabbit goes. So we can compare AMQP to HTTP because this is also a protocol. And in this stupid picture, we can see some example of having protocol. For example, if you want to ask the time, you need to say hi first. Otherwise, you wouldn't be considered polite, and probably the person wouldn't tell you what time is. Similar thing is happening between computers. As I already said, classical example is HTTP protocol, and we are all very familiar with that. So we can say that AMQP is another protocol, the same kind of HTTP. And the most important thing we need to keep in mind that it specifies middleware, but not the senders and receivers. So anything can produce and anything can consume. Any language, any technology. Of course, if this technology is capable to keep TCP connection and to satisfy the, for example, message rules of this protocol, it's going to be all right. So that's why you can implement AMQP things in PHP, in everything. And RabbitMQ is an implementation of AMQP 0.9.1. There is a newer version of AMQP, but Rabbit doesn't utilize this and doesn't really need it because Rabbit implements AMQP 0.9.1 completely, and also it has some extensions. So it can do even more than the protocol specifies. And in this talk, we will consider the opportunities provided by AMQP implemented in Rabbit and opportunities provided by Rabbit itself, which are not in the classical AMQP. Okay, so we know that AMQP is a protocol and RabbitMQ is the most famous and most popular message broker implementing AMQP. Let's start with some basics from the AMQP ideas, AMQP concepts. One of the most important concepts is message. And we need to keep in mind some very important points. For example, it's immutable, so you cannot change it during its lifetime. Message can have multiple attributes or headers, and some of them, they're used by Rabbit, by the AMQP implementation. For example, as I say here, durability, expire date, sometimes even routing can be specified in the header. But as well in the headers, you can send your custom information. And message body can be anything. Many people do JSON, but in fact, you can send anything, just unless your consumer knows how to decode this information. And Rabbit doesn't really care what's in. It doesn't read the content of the message. And another thing which is related to the protocol, each transferred message must be settled. It means that all the parts of this transaction, they must agree the final state of this transaction, which makes it reliable. A little bit later, we will consider an example. Okay, so we have learned one of the main basics, the message. Let's go to the next step and to learn something more about AMQP. AMQP also specifies order of doing things and the roles, I can say. Normally, it's implied that we have some application or something which is producing messages, we used to call them producers. Something in between, we used to call it queue or something like that. And something which is consumes, which is consuming, which is consumer. As I told you, producer and consumer can be anything. And this thing, this red thing in the middle is the middleware provided by the message broker, by Rabbit. Here we can see the schema of default exchange. And now that's the right time to test it, to see how it works. In my local, I have an instance of Rabbit running in my local Docker. And also I have the web interface here. I need to find out how to stop sharing. Yeah. So this is the web interface of RabbitMQ. This one is my local one. In the most of the installations of the Rabbit, you will have it. You need to refer to the documentation. It's a very convenient thing because from here you can access your exchanges queues, you can look into them, you can create them, and in fact you can produce messages from here, which is really cool. So we will be using this. We will be using this web interface as a producer, and also we are going to have a consumer. Because consumer is a little bit more interesting thing, we are going to have a real consumer written in PHP. So I have different kinds of consumers here. The first one we are going to work with is going to be a default consumer. In my implementation, I use Laravel because it gives a very nice interface for running the console commands. You can create a lot of your custom commands. So I decided to use Laravel to help me with that. And the only parameter of my console command is the name of the queue. Let's say that it's SydPHP August. And let's say August default. Okay, it's running. It doesn't output anything at the moment because my implementation of the consumer is super simple. So let's go to the queue and find it. SydPHP. As you can see, this queue appeared here. It was created when we were running our consumer. Let's produce some simple message. Just this emoji. Publish, message published. And as you can see here in the output of our consumer, we can see the message we have sent, this emoji. And maybe this level of abstraction is the level the most of the developers know, because it allows us to use the queues properly. Honestly, before digging deeper, I even thought that I can produce messages directly to the queue, and then something is just consuming these messages at the other end of the queue. So I thought that it's a very simple thing. In fact, it's not. Even though now I went to the queue and produced as it looks like to the queue. In fact, I didn't do this. What really happened? Where are my slides? My slides are here. Let's have a look at the real structure of the message broker. So we have publisher, which is anything. We have consumer, which is anything, but in between we have exchange, we have routes and queue. Exchange is the place where your message go initially. Publisher can publish only to the exchange. No publisher, nothing can publish messages to the queue. As well, nothing can consume exchange. So very roughly, you can say that exchange is more about publisher because you publish there, and queue is more about consuming because you consume from there. Exchange cannot hold your messages. You cannot keep them there. Exchange can only route your messages to the proper queues. But in queues, you can really store them in memory. From queue, you can consume them. But why? How did it work that we just create a queue? We didn't create any exchange. How did we produce a message to the queue? In fact, we didn't do this. If we have a look here in exchanges, we do have AMQP default exchange. This exchange is getting created by default. And if we produce any message here with routing key, which is equal to the name of our queue, it will go directly to the queue. So that's why sometimes we don't even know that exchange exists. But in fact, it does. So this was the most simple version of the message broker, when you only have default exchange and your custom queue. Let's stop our consumer now. Let's have a look at the implementation in the code. You can say that this is a classic code, as it was mentioned in the first talk. It breaks every single principle of Solid, but I just wanted to make it very visual. This is Laravel thing, just ignore it. So first step, we need to create connection. Connection in AMQP and Rabbit in particular, they are long-living TCP connection. So the connection is open, and it keeps being open until you close it. Be aware of that. So here we need to specify host, port, user, password, and virtual host, which is quite straightforward. By the way, the thing I'm using here, it's called PHP AMQP lib. This is a very, very low-level API for connecting to AMQP. So in SydPHP GitHub repository, in my talk, I have provided you with the link to this very basic API. It's a very low-level thing. Probably in production, you wouldn't use it directly. You would use some kind of abstraction over this low-level thing. But in this talk, we will focus on the low-level stuff. So here we can see that we have AMQP connection object, which is physical connection. It represents our physical connection, TCP connection. So we have created it. And the second step, we need to create a channel. In fact, channel, it doesn't exist physically. It's just a way of Rabbit to abstract. Like, it's a way of Rabbit to create a connection under connection. Because if you create too many physical connections, as you probably know, it's not always good. It can, by the way, we even ran into this problem. We were creating too many connections and our consumer was failing. So that's why you can keep the same physical connection, but you can separate your things. For example, you can have consumer and producer sitting at the same connection, but because you have channels, you can separate them so they are gonna be in different channels. From the API, you consider them, in fact, as different connections. But because they are channels, they're using the same physical connection, but from the API point of view, they're different, if it makes sense. In Rabbit of the current version, you don't work with connection directly. You do everything via the channel. So you can say that connection is physical, channel is abstract based on the connection. So step 3, we declare the queue. There is a very simple API command. It's called queueDeclare. Funny thing is that if the queue with this name and the parameters already exist, it will not throw any errors. It will just accept this fact. So every time you connect, you can easily run this command. It's not going to break anything. It's a good practice. So by running queueDeclare, in fact, you are checking if this queue exists. If it doesn't, it will create it. You need to specify queue name, which is quite obvious. Passive, you need to specify durable. This is super interesting thing. So if you say that queue is durable, it means that even when the AMQP server is down, when it restarts, your queue is gonna be resurrected. It's not going to die together with the server. You need to understand that if you make your queue durable, it gives you more reliability, but at the same time, your performance will lose. You need to keep this in mind. The next step, we are creating exchange. And at this point, we are going to create a real exchange, which is going to be SydPHP demo direct. This is the second type of exchanges, direct exchange. And for exchange, we can also specify type. We can specify if it's durable. Then we need to bind our and we specify the routing key. Is that callback. In this callback, we can do everything we want with our message. As you can see here, we just output this, so that's why we saw the messages in the output of the console. And another important step, we need to clean up after ourselves. We need to close channel and connection because it will be consuming resources. And the next one, we are going to make our process wait. So if you started this process, it will be working unless you stop it. Now let's run this. It's going to make the second type of the exchange is going to be direct exchange. So here we specify the name of the queue. Let's call it just direct, and routing key. I don't know, let's say Sydney direct. And let's find our exchange here. Our exchange is going to be direct, this one. And as you can see, we have a binding. Now, because we have binding, we need to provide the routing key. When we produce messages, we need to provide routing key. We need to provide the exchange name and the routing key. So as we specified here, our routing key is Sydney direct. Let's do it. And let's send something. Message published. As you can see, it appeared here. But if you don't provide routing key in the direct exchange, your message is not going to be sent. So you need to keep it in mind. And there is another kind of exchanges, which is called fanout. It's a very nice name. So you can bind any number of queues to the same exchange without any bindings. And then when you send a message to this exchange, it will send this to every queue subscripted to this one. So let's create this SydPHP August fanout 1. Okay, let's find it here, exchanges. This one, as we can see, we have this queue here. And let's say it's published. We can see it here. As you can see, we haven't provided any kind of bindings, but still it worked. Just because you can bind multiple things to fanout exchange. Let's say fanout 2. So as you can see, we are running another consumer in a parallel process. And we are going to send another message. Let's refresh the page. As you can see, we have 2 now. Let's say hello. We publish this message. And as you can see, it goes to both of them. This is how fanout works. And maybe the most complicated one is topic consumer. It allows you to send messages based on the routing key. So let's create this one and we will see how it works. So let's say that we create consumer topic and we create queue SydPHP topic 1. And let's say that we have the routing key, demo, everything. Okay, let's run it. And here, let's create another one, another consumer. It's going to be topic 2. And let's call it, for example, something 2. I will explain what it means. What's wrong? I have copied too much. Okay, so we have two consumers running, hopefully. Let's find our exchange here. Here it is. As you can see, we have routing key, demo something, and something too. This is placeholder. It means that if we publish demo 1 and say 1, demo 1 complies to this template. So it's going to be sent to the first one, but it's not going to be sent to the second one. Let's publish it. As we can see, here we have it, but here we don't have. Now let's say hi, and let's say hi to something which complies to both of the conditions. Let's say demo 2. Here, as you can see, at our placeholders, it's going to satisfy both of them. We say hi, and as you can see, both of the consumers reacted with hi. This is some nice features, some nice kinds of the exchanges, which can be quite useful. Have some more time. I want to speak about another very, very important thing, which is called acknowledgments. They are provided by the protocol itself, and RabbitMQ has some additional features. So when your consumer receives a message, it must say Ack, which means positive acknowledgement. It means that you say to the system that I'm happy, I processed this message. System just drops your message. You can say NAK. It's not a part of AMQP, and it reminds the word na, which is very Australian. And so this is, NAK has some more functionality in comparison to typical reject. Reject is the AMQP way of saying NAK. But NAK gives you more functionality because it allows you to reject multiple messages. So how it works, if you NAK with requeuing, it's going to requeue the message. So when you NAK with requeuing, the message returns back to the queue. And it's going to be placed to the same place where it was before you NAKed it. So by saying NAK with requeue, you're like saying, okay, let's try doing this again. Especially when you have multiple instances of the consumer consuming the same queue. You can say NAK with requeue, and if your first replica fails, the second one, when your consumer scales, may be successful. But it's very dangerous because if you requeue, if you NAK with requeuing, you may create an endless loop. So you will be requeuing, consuming, requeuing, consuming, requeuing, consuming, and it's gonna be something terrible. And this is how we implement NAK. A very simple thing. Just here we do Ack, but instead we would just say NAK. Very simple. And if we add the third parameter, false, false, the third parameter is the requeuing. By default, it false. We can say true. And we are happy to meet the endless loop right here. I have simulated this today morning, but I don't have time for this. So this is very important part. You need to acknowledge message, say Ack or NAK, if you are not happy with that. Next step, guarantees from AMQP. First, AMQP is going to drop message intentionally with intention only if every part of the system is happy with that. For example, if we act the message, it's going to be completely dropped. AMQP doesn't log them anywhere. It's going to be just dropped, going to the void. And if we NAK with no requeue, it's going to happen the same thing. This is what we know. So it will just drop your message, but it's not going to drop it itself by its own initiative, only if you, with your consumers, tell it to do it. Another thing is that message can be durable. As I already said, our queue can be persistent and durable. It means that they are written to the disk and they are going to be resurrected when your server recovers if it dies. The same with message. So if you send durable message to, I'm not sure what the correct wording, durable or persistent queue, the messages, they are going to stay there even if your server restarts. Also, AMQP can guarantee you the order of your messages. It can guarantee you that if you requeue the message, it will do its best to put it to its initial position where it actually was, not to the end of the queue. But still, there is no absolute guarantee that your message will be delivered. There are some very funny edge cases. Even though AMQP is reliable enough, it cannot give you 100% guarantee that your message will be delivered. Just a simple, stupid example. So that's a distributed system. In most of cases, we have a master replica and we have a slave replica, sometimes multiple slaves, ideally. So imagine the situation. We send the message, it's going to the master, then master dies before any replica synced. Then all this replica is getting to be promoted to become a new master, but because it hasn't been synced, it doesn't have your message. So it means that this is a classical way of losing your message forever. This is why some people, they use Apache Kafka instead, because Apache Kafka can provide you with these guarantees. There are some special ways which can guarantee you that this message is not going to be lost this way. But at the same time, AMQP can guarantee you that this message will be delivered at least once or at most once, not exactly once. There is a hacky way to implement exactly once in AMQP, but in fact, it's not going to be asynchronous because you would need to wait in your initial process for your consumer to consume it. And unfortunately, I don't have time to talk about dead letter exchanges, but just quickly say message goes to the dead letter exchange if it was negative acknowledgement, if it exceeds its TTL, if it expires, just as my talk now, and if your queue is too long, it's also going to go to dead letter exchange. But these dead letter exchanges, they are not getting created automatically. You need to create them themselves. And sorry for taking your time, but I really want to show it to you. So this is how we can replace step number 3 with creating a dead letter exchange. So this is not AMQP, this is pure Rabbit. So when you create a queue, you specify dead letter exchange. And the letter exchange is just a normal exchange. Any exchange can be your dead letter exchange. So you can say that, okay, if something failed in my normal queue, it's going to go the second way, to go to the dead letter exchange. And this dead letter exchange is going to route your message to the queue you specified. So if you do it properly, when you have some problems, you will find your problematic message in the dead letter queue. This is a great way of on doing this thing. Actually,